Good morning, my dear students. Day 2. Today, let us discuss about distance and displacement. Today, let us discuss about distance and displacement. It is a very easy concept. If you can observe this lecture very clearly, I have given you some assignments. You can solve those assignments. It's very easy chapter. Distance. For example, there are two stations named A and B. There are two stations A and B. I want to move from point A to B. So in how many ways can I reach from A to B? Obviously there will be several ways to reach from A to B. For example, from your home to your school, there will be definitely many paths, many ways. Here I have a path number like this, say path number 1. I can move like this. So this is path number 2. This is path number 3. I have many ways to reach from A to B. And one more path, that is path number 4. I'm sorry. This is path number 4. So in any path we can reach B. But what will be the difference? The difference is time and fuel, energy. So the only difference is the time and fuel consumption. So in which path, assume that all are roads only, fair roads. In which path we can reach B in less time? Yeah, definitely path number 4. Imagine that you are walking with constant speed. If you are walking with same speed, then in which path you can reach the destination in less time? Obviously, path number 4. What is the specialty of the path number 4? Yes, it is a straight path. And one more thing is, it is the shortest path. It is the shortest path. That's why it is very, very special. Remaining are greater paths than 4. Which is next greater path? 1. Next 2. Next one is 3. So all these 3 are different, and this 4th one is different. It is very, very special path. This special path is known as displacement. Now can you tell me what is displacement? The shortest path connecting it between 2 points is called as displacement. Other than this, if you take any other path, those paths are called as distances. So this is distance, this is distance, this is also distance. Only path number 4 is called as displacement. Other than this path 4, the remaining are distances. Is it clear? What is distance? The path length is called as distance. You may go to one doubt. Sir, you are saying that path length is called distance. Means if I take the straight line, this also has path length. Can we call this as distance? Yes, you are right. You can call this path number 4 also as a distance. Means 1, 2, 3, 4. 4 are called as distances. No doubt in it. But path number 4 has additional quality, that's why it has an additional name. What is the additional quantity? It is the shortest path, that's why it is called as a displacement. We can call this as distance as well as a displacement. Now, can we call this as displacement? No. Can we call this as displacement? No. Can we call this as displacement? No. All these are distances. Can we call this as displacement? Yes. Can we call this as distance? Yes. This is distance and displacement. This is distance only. This is distance only. This is distance only. Other than this, the remaining are distances. This is distance as well as displacement. From this figure, it is very clear that distance is equal to, this is distance and displacement. Distance is equal to displacement. From these diagrams, 1, 2, 3, from the 1 to 3 paths, distance is greater than displacement. Means distance can be equal to displacement or distance can be greater than displacement. Means we can simply write that distance can be greater than or equal to displacement. What about displacement? Displacement is equal to distance only one time. Remaining all the times it is less than distance. Is it clear? Now let us see some examples. I will give you some examples. You can find these examples in our worksheets. You can solve those worksheets by observing these examples. Come back. Let us see some gardens. Say this is a circular garden of radius r. There is a circular garden of radius r. A gardener starts from point A. A gardener starts from point A. There is a circular path. He travels along the circular path and reaches point B. Next, he reaches point C, which is diagonally opposite. Next, he reaches point D. Then he comes back to point A. So what happened here? He reaches from A to B. Next, A to C. Next, A to D. Next, he came from A to A. In these cases, what is his distance and what is his displacement? This is the question. Got my point? So as he is moving like this, what is his distance and what is his displacement? You can pause my video and you can try, and later on you can check your answer with me. Make a table and try. I am giving you 1 minute time. Pause my video for 1 minute and try, and then check your answer. Yes, come back. I hope everybody tried. Well done. Let us check your answers with me. Now AB means this is. What is the path length? This is the path length. This curved path is a path length. I hope everybody is aware of the circumference of a circle or perimeter of a circle. What is the perimeter of a circle? Perimeter of circle is 2 pi r. Obviously, it is very clear that this is 1/4 part of the circle. That's why this path length will be 2 pi r by 4. Means pi r by 2. Next, what is the displacement? The shortest path between 2 points is called as displacement. So, if I take a straight line, this is my shortest path and this is my displacement. As this is a circle of radius r, this is also obviously r. It is a right angle triangle. In the right angle triangle, this is r and this is r. What about this is root over r square plus r square. Hypotenuse. Hypotenuse is equal to under root side 1 square plus side 2 square in case of a right angle triangle. So if you simplify, what is this? Root over 2r square, which can be simplified like 2 root root 2r. So this is root over 2r. This is our distance. Displacement. This is our distance. How many of you did like this? Good. Now let's see AC. This is a point A. This is a point C. He is moving like this. So definitely remaining people can answer this. This is half of the circumference. What is the circumference? A perimeter 2 pi r. So this is the 2 pi r by 2, which is equal to 1 by r. Now what about the displacement? Shortest path between initial and final points. This is our A, this is our C, this is our straight line path. So this is our r, this is also r plus r, 2r. Next come to AD. So it's moving like this and it reaches point D. What about this perimeter? 3 parts. Out of 4 parts, it is part 1, part 2, part 3. So each part is equal to pi r by 2. That's why this is pi r by 2 plus pi r by 2 plus pi r by 2, which is equal to 3 pi r by 2. What about the displacement? Initial point, final point, shortest path. Again, this is our rectangle, triangle, 90 degrees. That's why this is our root over r square plus r square, which is equal to